Okay. Okay, good morning everybody and welcome back. Today is day 3 of the engineering survey exam preparation class. Let me reiterate my contact information. If you have any questions at all between now and test time, please don't be afraid to give me an email, okay? Today is, I think, the best day of the seminar. Why is it the best day? Because it's the last day, exactly. Okay, I want to make sure that everybody got a copy of the solutions for the practice exam. Let me put that up and show you what I'm talking about here. Once I find my mouse here. This one here, okay? The practice exam. So everybody at home, you should have got a PDF copy of that this morning, and I'll give a handout to the people in class today. So let me know if you did not get that, and I'll make sure you do get it. Last week, we talked about, wait a minute. Last week we completed a lot of information. We talked about topographic surveys, photogrammetry, GPS, GIS, vertical curves, and horizontal curves. So before we get into the new material, does anybody have any questions about what we covered last week? If not, we'll go ahead and go over the homework. Paul, you good? All right, we'll go ahead and go over the homework first of all. The first homework problems are located in Chapter 18, and we're going to begin on page 325. So on page 325 at the top of the page there, number 2, a transit with an HI. What's HI stand for again? Height of instrument. And the way that is determined is, if you look on the side of the instrument, basically where the axis of the telescope is, there's a little dot on the side, and you measure from the ground up to that dot, and that is your height of instrument, okay? Normally it's around 5'3", somewhere around there, 5'30", something about that, unless you're really tall or really short. Okay, we're given a transit is sitting at station 2 with a given HI and a given elevation. And you're sighted at point 18 with the following results. We're given 3 rod readings, the bottom hair, the top hair, and the middle hair. And we're also given the vertical angle. Just go ahead and give it to Paul right there. Okay, determine the following. The horizontal distance from station 2 to point 18 and the elevation of point 18. Okay, so we're on page 325. We're going over the homework, okay? All right, so the solutions for those are shown in your book, beginning on page, let's see, at the bottom of page 331. Right here. Okay, so let's draw a picture of that to make sure we all understand what's going on here. So here's the solution here. We're solving for the horizontal distance and the vertical distance. So looking at, or putting together a picture here so we can understand what's happening. We're located at station 2. The vertical angle is a plus, so that means we're looking up. So it kind of looks like this. At the bottom of the hill is station 2. And the elevation there is given to be 291.7. The HI is given 5.13. And we're looking up at the rod. And we want to determine H and V. Okay? And we also know that this vertical angle here is 1 degree and 56 minutes. Okay, everybody see the picture there? Okay, now we're going to go ahead and solve it. And as shown in the book there, the letter H, or the horizontal distance between the 2 points, is equal to what we want to do there is first determine what the, let's see, what do we got here? So the crosshair reading, the middle reading, so when you look through the transit, kind of looks like this. So we have the top hair is 583. The bottom hair is 443. And the middle hair is 513. Okay, so to determine H, we're going to take the top hair minus the bottom hair times 100, and what's that 100 called? The Stadia interval factor. Okay, the Stadia interval factor. And then we're going to take that times the cosine squared of 1 degree 56 minutes. For the vertical component, we'll take 100, and that's the Stadia interval factor. Here's our Stadia interval factor. The top hair is here. The bottom hair is here. Now what's going on here with the sine cosine thing? Remember, if we were looking at it on a horizontal line, a horizontal plane, all right, it would be just the difference in the rod reading times 100. In other words, if we were looking at it on a horizontal, it would be just this and we're done, okay? But because we're looking at it on an angle, there's some little bit of geometry going on there. And basically, you've got this little right triangle here that you're solving for, okay? That's what's going on there. So in other words, we're not looking at it level, we're looking at it on an incline, okay? So for the horizontal, we're going to take the cosine squared times the vertical angle, and to determine the vertical difference, we're going to take the cosine of the angle times the sine of the angle, okay? So once we get the horizontal and the vertical, we know what the horizontal distance is. To get the elevation of point 18, we're going to take the given elevation of station 2 plus the HI. That's going to get us to here. And then we're going to take the rod reading up here, the center rod reading, all right, and subtract that from the elevation. And that will give us the elevation here, okay? Any questions on that one? Alrighty, let's move on to the next one then. The next one is a horizontal curve problem on page 325. Okay, right here. So we're given the PI at a station at the PI, a central angle and a radius. Compute the tangent and length of arc. Okay, the tangent and length of arc. So that's shown. Remember, any two parts that are given for a horizontal curve, we can solve for the rest. So the solutions are shown in your book there at the top of page 332. So the tangent is equal to r times the tangent of delta over 2, and the length is equal to 2 pi r times the delta divided by 360. Another way of saying that is the length is equal to the delta in radians times the radius. Okay, so that's just another way of putting it. Any questions on those? Okay, excellent. Now we get into the practice problems and out the solutions for those. The answers are in the books, just the letter answers, but I wanted to give you the solutions as well. So let's all turn to chapter 17, beginning on page 293. All right. So the first one is actually number 9 is on page 296. Okay, so looking at this one, how many parts of the curve do we need to solve? Do we need in order to solve for any other part? Not one, but 2, right? How many are given in the initial problem statement? Okay, there's one right there, right? The radius is given. Okay, is anything else given? What's that, Sol? Excellent. We're giving the station at the beginning of the curve and the station at the end of the curve. We simply subtract those two. Remember that horizontal curves are stationed along the arc. And simply subtracting those two will give us the length. So when we do that, we come up with a nice even number. L is equal to 1,000. So now we have 2 parts for the horizontal curve. We then solve for the central angle, and that ends up being 60 degrees. And then we're going to construct this small right triangle here, knowing because of the geometry of the horizontal curve, that angle is also 60 degrees. We know that this is 100. And we're going to solve for the hypotenuse, and that's the distance between P1 and P2. Using the sine function, we come up with a distance of the hypotenuse of 115.47. We simply add that on to the BC station to give the new BC station. So letter C is the correct answer, letter C. The next one is number 10. And again, I kind of